Hello, level threes. Welcome back to another lesson on organic chemistry. So we've done aldehydes and ketones, and we've learned in the last video that alcohols get oxidized not necessarily in the one step to get to a carboxylic acid, but that there's an intermediate step called an aldehyde or ketone in between. And when we see that aldehydes form when primary alcohols get oxidized to become a double bonded OH, and then get further oxidized to become a carboxylic acid, and then ketones being secondary, coming from secondary alcohols. Alcohols get oxidized and form ketones, and because that double bonded O is in the middle of the molecule, it can't be oxidized further, so that's where they stop. So today we're going to go and just see what the different conditions are, how the setup is, and how do we get to, what's our glassware like and our setup like in order to get to an aldehyde or carboxylic acid at the end. Okay, so there's two different ways that we can do it. The first way is by using distillation, and then the second one is having a reflux, or doing it under reflux. So the two distillation, and I'm hoping that you've seen a distillation tube before, is a glass tube, and what happens with this glass tube is it's attached to the flask where the reaction is taking place. So we'll say that that's there, and what happens is because the solution usually gets heated, and there's two different solutions potentially in that flask. One boils at a lower temperature than the other one, so it'll start evaporating. And when it gets into this little tube in the middle, we put cold water through on the outside. So the outside sweet cold water gets circulating around to cool the inner tube. And what happens is this gas that comes through and moves through the tube condensates, and at the end becomes little water droplets that we form at the end. And then we have a liquid at the end that we could collect, and that's how we separate two different liquids with two different boiling points. Okay, so this is a setup that we use when we oxidize an alcohol to become an aldehyde, and we want the aldehyde at the end. So an aldehyde will get oxidized, and as it oxidizes, it becomes a gas, and then it travels through the tube, and as that tube cools down the gas, it becomes a liquid, and then it collects at the end. So that's distillation. But sometimes we want to go further, and we want to actually try and make a carboxylic acid by going through this whole process of oxidation of an alcohol. But if we do it through a distillation with a distillation tube, what's going to happen is this aldehyde will get released, and then it won't have that chance to get further oxidized. So this is when reflux is needed. So reflux is pretty much the same tube. It's a bit shorter, but we could say it's the same one. And what happens is we don't use this tube like this to make the liquid escape at the end. We turn it upside down, the tube. And when we turn it upside down, so it looks like this, we still have this water going in and out, circulating around the inner tube. And we have this collection tube, or the flask that we have at the end. So we have that's connected, we'll just put so we connect it that way. So we have our alcohol at the end, at the bottom, and we are oxidizing it. And then as normal, the alcohol gets oxidized to become an aldehyde. This aldehyde will move through the tube, and because the cold water is circulating the inner tube, the aldehyde will cool down before it reaches the end and gets released. So what happens then is it cools down, becomes water again, a liquid, and then it trickles back down all the way back into the flask. And then it heats up again, it gets oxidized, and it becomes an aldehyde again, or it might stay an aldehyde, it evaporates again and cools down and then goes back in. So at the moment, there's no way for this aldehyde to escape this reaction. So it could go into the tube, but it's always going to go back. and that increases the oxidation of an aldehyde and forces this aldehyde to become a carboxylic acid. Okay, so the two setups are really crucial in whether we want an aldehyde or a carboxylic acid at the end. So aldehyde, distillation is needed for an aldehyde because an aldehyde forms and it cools down and we can let the aldehyde at the end. If we want the aldehyde to get further oxidized, we need to put it into a reflux tube. And the reflux tube, because it's upright, the aldehyde will cool down and then trickle back into the container to get further oxidized. So we're forcing the aldehyde to oxidize further to become a carboxylic acid. So those are the two methods for oxidizing alcohol to become either an aldehyde or a ketone or a carboxylic acid.